Today we'll find the maximum and the minimum of a function. Let's say we have f of x is equal to x to the 3 minus 3x squared plus 2. Finding the derivatives of this function will be helpful to find the maximum and the minimum. If we take the first derivative of this function, we have 3x squared minus 6x. Now let's equal it to 0, equals to 3x squared minus 6x. The reason why we take the derivative and then equal it to 0 is because when we have like a turning point, like a maximum or a minimum, the slope is equal to 0. So that's why here we're equaling it to 0 with the derivative. So if we solve this, we have 3x in common, x minus 2. So x is equal to 0 and 2. Now, as you know, derivatives are about slope. So if we have f of x bigger than 0, it means that the slope is increasing. So if we have a positive slope, we are increasing. If we have a negative slope, meaning less than 0, we are decreasing. If we take the second derivative of the function, we have 6x minus 6, and we plug it in these two values of x where the slope is 0. So when x is 0, we have minus 6. When x is equal to 2, we have 6 times 2 minus 6. So 12 minus 6 is just 6. So here, if we interpret this result, we have a maximum here, and we have a minimum here. The second derivative of a function, it indicates you the concavity of a function. So if taking the second derivative gives you a number that is bigger than 0, we have a minimum because it's concave up. So it's going to be like this. And when it's like this, we have a minimum. If we have the second derivative as smaller than 0, we have a maximum because we're concave down, pointing towards downward. So we have here a maximum, which is why here when we had minus 6, we were here. That's why we have a max. And when here we got a 6, we got our minimum. When the concavity changes, we have an inflection point. Basically, when we're going from a concave up to concave down or a concave down to a concave up, we're changing the concavity, and that is when we have an inflection point. And the inflection point is when we have our second derivative and we equal it to 0. So 0 equals 6x minus 6, which is equal to 6 over 6. So x is equal to 1. So when x is equal to 1, there is a change in concavity. As for our result, here we had a maximum. It means we had a concave down, and here we had a minimum. So it means we have a concave up. So when we change in concavity, so we are going from concave down to concave up when x is equal to 1. As per what we found, we had 2 points. This is our maximum when x is equal to 0, and we have our minimum when x is equal to 2.